Hello, everyone. I wanted to make a quick video for you just to help you in section 5.4, I believe is where this one's going to come up. So this was from the 5.4 and 5.5 in class. We went through these guys really quickly at the end of class, but especially this um, integrating an absolute value idea is going to come back for us in section 5.6. And it's something that I want you to have a pretty solid grasp of. So I wanted to spend a little bit more time um, going over how to integrate an absolute value and what that means. Okay, so let's just work this problem because this is one that we haven't seen before. So I want to integrate from 0 to 4 the absolute value of x squared minus 3 dx. So this really says that I want to find the signed area trapped between y equals the absolute value of x squared minus 3 and the x-axis, from x equals 0 to x equals 4. Okay, so that's what this is finding. But the question is, how do I actually go about doing this? The thing about an absolute value is that we don't have like a set, um, I guess, function for an absolute value. What the absolute value does is it creates a piecewise function that takes your regular y values, x squared minus 3, wherever x squared minus 3 is already positive, and then anywhere x squared minus 3 goes negative, the absolute value is going to turn us positive. Now, how do I do that? Well, the way that we're going to have to start these is that you have to figure out where the function inside the absolute value bars is above the x-axis, where our y values are positive, and where that function is below the x-axis, where our y values are negative. Okay, so there's a couple of different ways to do this depending on if you're more of a visual person or if you're more of an algebraic person. I'm going to show you both ways. That way you'll have, you know, um, the skills to work with your brain. So I'm going to start graphically on this one, and then I'll start algebraically on the next one. So x squared minus 3. I know what that looks like. Y equals x squared minus 3. This is an x squared graph. That's a parabola. But this minus 3 shifts us down 3 units. So basically, I'm going to take a parabola and I'm going to shift it down 3 units, and it looks something like this, right? Parabola shifted down 3 units. And I want the area from 0 to 4 of the absolute value. Now, the thing is, the absolute value is going to take any places in here where my function, my y values are negative, and it's going to turn them positive. So we're going to have to be careful with this, and we have to figure out exactly where this thing is positive and exactly where this thing is negative. So I know that I'm negative from 0 to whatever this point is, and then I'm positive after that. So I have to figure out what that point is. So your x-intercepts here, where y equals 0, are going to be these points where you switch from positive to negative. These are going to end up being the places where we have to split our integral into pieces. So to find that, you're going to start with your x-intercepts. You're going to set y equal to 0. So I'm going to figure out where 0 is equal to x squared minus 3. So we'll add that 3 to both sides, and so I'll get 3 equals x squared. And then I'll take the square root of both sides, and I'll get that x equals plus or minus the square root of 3. So this point right here is where x is equal to the positive square root of 3, and y is 0. This one over here, this is where we have the negative square root of 3 and 0. I won't need the negative one here. That's not part of my integral, right? That's outside of my area bounds, so I won't have to worry about this one, but it's there. Um, okay, so if I want the area from 0 to 4, but I want everything to be positive, then I'm going to have to split this function right here at x equals the square root of 3. So anywhere where my function is negative, so here from 0 to the square root of 3, um, this is where my function is negative, so I'm going to have to manually make that positive. In class, I think I put the negative on the outside. You can put that negative on the inside or the outside. Um, it's really going to come out in the wash because you can pull constants out of an integral. So I'll just keep it on the inside this time. We're going to take our y values and multiply them by a -1 to turn these negative y values into positive y values. That way our area will end up being positive there. And then I'm going to add to that the places here where my y values are already positive. So that's going to be from my splitting point, the square root of 3, until the end of my integral to 4. And in here, my x squared minus 3 y values are already positive. So I'm just going to take x squared minus 3 as is times dx, and I will end up with positive area. Now, if you weren't graphic and you can set your y equal to 0, right? Set your function in those absolute value bars to 0 and solve for x. This will tell you where your splitting function, where your integrals split, but it might be harder to figure out which side the negative goes with. And to do that, you can always put this on a number line. The square root of 3 is where we're going to split my function. And then from here, we can test values on either side to figure out whether or not our y's are positive or negative on either side. So I'm going to pick something less than the square root of 3. How about 1? Right, the square root of 1 is 1. Or I guess 1 squared is 1, so that's smaller. And then I'm going to pick something bigger than square root of 3, which is 2, right? 2 squared is 4. So this is the square root of 4, which is definitely bigger than the square root of 3. Okay, so these are my test values. Now I want to figure out where y is positive and y is negative. So I'm going to plug these x values into my original function, into x squared minus 3. So if I plug x equals 1 in there, I'm going to get 1 squared minus 3, and that's going to be a y value of -2. That means my y values are negative there. And then if I plug 2 into my function, I get 2 squared minus 3. 4 minus 3 is 1. That's positive. So you're going to take the parts where your y values are negative, and you're going to have to manually add that negative to make them positive. And anywhere they're positive, you're going to take your function as is. This x-intercept is going to become your splitting point for your integrals, and your original bounds will still stay here and here. Well, overall, we're starting at 0 and ending at 4. We're just splitting it in the middle. So hopefully that helps you with the setup. And then from here, you can work each of these integrals individually, right? So here in that first one, you'll distribute that negative. Sorry, here we go. You'll distribute that negative, and then you can kind of work that from 0 to the square root of 3, negative x squared plus 3 dx. And you'll add to that the integral from the square root of 3 to 4, x squared minus 3 dx. And then you'll work each of those individually, just like normal. I trust you to complete that. I think splitting these is the hardest part. Okay, so hopefully that makes sense. Let's try one more. And we're going to do this one starting algebraically, and then we'll come back to a graph depending on how your brain works. Okay, so if I'm going to split this, I need to know where this thing is going to be, where my y values for 5 minus 2x are going to be positive and where they're going to be negative. So we have to start by finding our splitting points. So that's where 5 minus 2x equals 0. And so that's going to happen where 5 equals 2x, which means x is 5/2 or 2.5. Okay, so I know that I'm going to split this thing. Oh, that's 2.5. So sorry, this is what happens when I make these up off the top of my head. Let me come back here. Let me change this to um, a 5. Okay, sorry, y'all. Made this up off the top of my head, so things got a little wonky. Okay, so 2.5 or 5/2. This is where my splitting point happens. And so now my splitting point, 2.5, is between my bounds. So I know that there are places where this thing is going to be positive and places where this thing is going to be negative, and we have to figure out where that happens. So I'm going to pick some test values on either side of 2.5. So I'll pick one over here. Bigger than 2.5, I'm just going to say 4. All right, so I'm going to plug these into 5 minus 2x to see whether that's positive or negative on either side. So if I plug 1 in, I get 5 minus 2 times 1. That's 5 minus 2, which is 3. We're positive over here. That's where my y values are positive. We're above the x-axis. And if x equals 4, I get 5 minus 2 times 4. 5 minus 8, that's negative 3. And that means that my y values are negative here. So if I'm splitting this into two integrals to be able to evaluate this, I know that from -2, right, that's my starting point, up until 2.5. So from -2 to 5/2, my function's going to be positive. So the absolute value of 5 minus 2x is going to be whatever 5 minus 2x is, because it's already positive. And then I'm going to add to that the integral from my splitting point, which is 5/2, up until the end of my interval, which is x equals 5. And I'm going to integrate the absolute value of a negative. In order to make that negative come back positive, I need to manually multiply that negative by another negative to make it positive. So I'm going to have negative 5 minus 2x dx. And now this integral will make all of my negative y values become positive, and we've essentially evaluated that absolute value by hand. So this 5/2 becomes your splitting point, and your bounds still go from -2 to 5. Positive, you keep your function the same, and wherever you're negative, you add that negative in front of your y values to make them positive. Okay, so that's how you would do this algebraically. If you were visual, I would graph y equals 5 minus 2x. This is a line, right? It has a y-intercept of 5, 1, 2, 3, 4, 5. And I have a slope of -2. So that means I'm going to rise -2, run 1, rise -2, run 1. And we can keep going, right? It'll be a straight line. So I look like this. Pretend that all of these points are on there and it's a straight line. um, so I have a line here. And so I know this function is above the x-axis over here, and it's below the x-axis over here. So I would need to find out what this x-intercept would be. And again, to find that, you're going to set your y value equal to 0, which is right here. You'll solve it out and you'll get x equals 5/2. So this is the point 5/2, 0, right? 2.5, 0. And I know that anywhere on the left of that, my y values are already positive. So from the beginning of my interval, -2, to my splitting point, 5/2, I'm going to take the function as is. And anywhere to the right of 2.5, my y values are negative, which means I need to add on this negative to make those y values come back positive to make the absolute value happen. and that's going to be anywhere from -5/2 to +5 inside my interval. So again, you can do it graphically if you like that way, or you can use a number line and do it more algebraically to figure out where you're positive and where you're negative and how to split those integrals up. Okay, I hope that helps get a little bit more familiar with your absolute values. We did also kind of rush through the piecewise functions, but I do think these kind of make sense, right? Because just by the um, meaning of what a piecewise function is, if you want to find the area underneath f of x from 0 to pi, f of x is going to be the sine of x for all x values less than or equal to pi. So you're going to find the area underneath the sine of x for all your x's less than or equal to pi. So that's why this is 0 to pi of sine of x. You're just basically finding the area under this one for all of the x values in your interval that apply there. And then you'll add to that all of the x, or all of the area underneath this function for the x values that it applies to. So to find the area underneath f of x, you're finding the area underneath -2 sine of x. And that's only for x values that are bigger than pi, which in our interval just is pi to 2 pi. So again, you're splitting these up, but I think between the way that piecewise functions work, and hopefully you've had practice with piecewise functions to know what those look like, um, you'll find the area under each function where they apply in your interval. Okay, I hope that helps with that homework and just getting more comfortable with those absolute values and manually making them an absolute value. Um, Let me know if you have any questions. Otherwise, I will see you on Monday to finish out 5, 6, and the Calc 1 material. Have a lovely weekend.